Hey, this is Anthony Wise. This is for MathLogic course 5154. This is for the question and answer video for languages, which was the video for today. So the two questions I had, the first one is, when is it useful or appropriate to have a lattice that is not distributive? I know distributive completive lattices lead directly into like Boolean algebras, which is useful for programming languages. But when is it appropriate to have a lattice structure, or useful to have a lattice structure that's not distributive? And I'm trying to find a use for that, but I haven't come up with something yet. I don't have a lot of experience with languages, so anyways. And then the second one is a little more interesting question. I read a book on graph theory. It's probably been a year or so, just an introduction to graph theory. Had a lot of interesting topics in it, just kind of an overview. But the second question pertains to that. If a lattice has a M3 structure, then it is not distributive, right? But if you look at the M3 structure, because it's got a 0 and 1 on the for the bottom and then for the top, and then you have the three components in the middle, which is A, B, and C. If you actually look at that, it doesn't have a Hamiltonian path in it, which is from graph theory. Meaning you can't start it and get all the way through and end up back in the same place. And I thought those two things are very similar, because that structure means that the lattice itself cannot be distributive, and it also doesn't have a Hamiltonian path. I didn't know if there was a process for finding the M3 structures within lattices, because I mean, if you have lattices that are infinitely tall, specifically like for powers, like in the example given in class, how would you find that M3 structure? And if you could find it, could you transfer that over into a part of graph theory for finding Hamiltonian paths, or saying that there's not one within the set of vertices and edges? Anyways, I just didn't know if that was significant or not. Looking into it, it's just kind of even if it's not related, it's just kind of interesting to think about. So those are my two questions. Thanks.